Hello there, this is Math 18, Section 3.5. Today we're going to look at writing equivalent fractions. So we have two objectives: how to write a fraction in simplest form, so in other words reducing your fractions, and how to find equivalent fractions by raising to higher terms, so you're going to be building equivalent fractions. So, when you are writing a fraction in simplest form, it means that the numerator and denominator have no common factors other than 1. So if you look at the two fractions, 4/6 and 2/3, those are equivalent fractions, because if you took 4/6 and you divided both the numerator and the denominator by the same number, by 2, you would get 2/3. So that's what we're going to look at doing first, is simplifying fractions or reducing them. So the whole idea there is basically that you are dividing the numerator and denominator by the same common factor. That's the whole idea. So this is actually using the multiplication property of 1. The multiplication property of 1 is used to write fractions in simplest form. So basically what you can do, now this is the long way of doing the problem, is you can write the prime factorization of the numerator. If you look at this example, 4 is 2 times 2, and then on the 6 on the bottom it's 2 times 3. And then you cancel any corresponding or common factors. The 2's are the same top and bottom, so if we divide or cancel those out, what it leaves is a 1, not a 0. Okay, so you eliminate those common factors and then you multiply what's left. 1 times 2 on top is 2, and 1 times 3 in the denominator leaves 3, so you get 2/3. But the thing that's important to realize here is that you have to divide or cancel the top and bottom by the same factor. Very important. Okay, so here's the directions. Now these directions are for, I would say, for really large fractions that you can't figure out what the common factor is. One way that you can always fall back is to fall back on these directions. To write the prime factorization of the numerator and denominator, then cancel any common factors that match in the numerator and denominator, and multiply what's left. Okay, so if we have 15 over 40 and we want to write this in simplest form, you want to look at the 15 and the 40 and say, okay, what factor goes into both? Well, 5. And if you can't figure it out right away, you can usually kind of go through the factors of the smaller number and you can usually figure out what the common factor would be. So what I'm going to do is I'm going to divide the top and the bottom by 5. So on top, 15 divided by 5 is 3, and 40 divided by 5 is 8. Now you look at 3/8 and you say, okay, will anything go into both 3 and 8? No. So that's the simplest form. Number 2, 6 over 42. Well, a lot of people might see 2 goes into both those, but think about it. 6 goes into 42, and it also goes into itself. So you want to try and use the greatest common factor, which in this case would be 6. So we're going to divide the top and bottom by 6, which would be 1 on top, and 42 divided by 6 is 7. Okay? All right, now look at 8 over 9. Is there anything that goes into both 8 and 9? No, just 1. So this is already in simplest form. So you could either just write 8/9 again, or if you're working in your online program and it asks for something like that, it may say something like already simplified or in simplest form, something like that. But you cannot reduce 8/9. Okay? Now look at 30 over 12. Some people may look at that and see 3. Some people may see 2. Some people may see 6. Now, I'm going to show you two different ways to do this so that you'll see that no matter what you do, you can't really screw it up that much. 6 is the biggest common factor. If we divide the top and bottom by 6, okay, that would be 5 on top, and 12 divided by 6 would be 2. So you'd end up with 5 over 2. But let's say, for instance, that you looked at 30 and 12, and the first thing you saw was 3. So if you divide by 3 on the top and bottom, you're going to get 10 over 4. Now, 10 over 4, those have a common factor of 2. So I can divide the top and bottom by 2. 10 divided by 2 is 5. and 4 divided by 2 is 2. So you still get the same answer. It doesn't matter which way you do it. The first step, when we divided by 6, yeah, that was the greatest common factor. So that's like a nonstop flight. You're there in one step, okay? Well, when we divide by 3 or 2 first, you're taking the scenic route, okay? Your plane is stopped in Atlanta, and you're changing planes, and you're running to the next terminal. Just kidding. All right, but it's going to take longer. Here's the thing. Does it matter? No, you all get to the same final destination. So you'll all get to the same answer as long as you're careful about your canceling. So if you don't see 6 right off the bat, remain calm. You will get the final answer. You'll just have to reduce 2 times. All right, so look at number 5, 54 over 6. You can divide, actually that divides out nice and even. 54 divided by 6 is just 9. Now let's say you didn't notice that and you just decided to divide the top and bottom by 6. Well, if you divide, I can't write a division sign, divide by 6 on the top and on the bottom, you get 9 over 1, which is the same thing as just 9. So the simplest form there is just 9. All right, now the next one, number 6, we have negative 150 over 105. Let's see, I know 5 will go into both of those. So I'm going to start with that. And there may be a bigger number, but I'm just going to go with what I know. Okay, that just seems to make it easier. So 150 divided by 5 is going to give me 30. Notice that I went ahead and just brought down the negative sign so I don't forget it in my final answer. All right, 105 divided by 5 is 21. Is that right? Yes. Okay. Now, you want to look at 30 and 21 and see if there's a number that goes into both of those. Well, 3 goes into both those. So we reduce again. Divide by 3. So we have negative 10 on top, and 21 divided by 3 is 7. So technically 15, because 5 times 3 would be our greatest common factor. But I'll tell you what, I don't know my 15 times tables. I stopped at 12. Probably you did too. So you can still get there just by going with what you know. So the final simplest form there is negative 10 over 7. All right, now look at number 7. This one looks horrible. But what you can do when you have 7,500 over, what is that, 25,000, you can cancel if they're whole numbers, zeros at the end. You can just cancel those out. So you have a 0 and a 0, they're gone. A 0 and a 0, it's gone. You cannot cancel the other 0 on the bottom because we've run out of zeros on top. Technically, what we just did was dividing by 100. It's just a lot easier just to cancel zeros, though. So here's what we're reducing now. 75 over 250. Okay, so I don't know about you, but I would see 25. I think of quarters. Okay, so divide by 25. Now, if you didn't see 25, would dividing by 5 be okay? Heck yeah, you'll still get the final answer. Okay, 75 divided by 25 is 3, and 250 divided by 25 is 10. So that 3 and 10 don't have a common factor, so that's it, 3/10. Okay, now 32 over 48. Let's see, 8 will go into both those. So if I divide by 8, I'm going to get 4, and 48 divided by 8 is 6. So see, even I didn't find the greatest common factor there because I can reduce 4 and 6 by 2, so I can go one more time, and that would give me 2/3, and that is in simplest form. So if you don't see the biggest common factor right off the bat, it's okay. You just have to keep reducing as long as you can. That's all. All right, so here's some for you to try. 12, pause the video. Always forget to say that. Pause the video, try these on your own, no cheating, and then check them out, okay? All right, number 1, write in simplest form. 12 over 16, 4 is a common factor there. So if I divide by 4, I'm going to get 3 over 4, and that would be it. Okay. Now, negative 70 over 49. I see 7 as a common factor there. So I'm going to divide by 7. So don't forget your negative sign, and that would be negative 10 over 7. One thing you should notice, we started with an improper fraction, the 70 over 49, and we're ending with an improper fraction. So that's good. If you start with an improper and it comes out proper, something ain't right. Okay, so you messed up somewhere. So be careful. All right, what about 8 and 80? Well, 8 will go into both of those. So I'm going to divide by 8 on the top, divide by 8 on the bottom, and that's going to give me 1. And 80 divided by 8 would be 10, so 1/10. And number 4, we've got a set of zeros that we can cancel at the end. Just knock those off. So we've got 14 over 42. And let's see. I would probably see 2. That's just an easy go-to. If they're both even, you can always use 2. That always works. So 14 divided by 2 is 7. And 42 divided by 2 is 21. Now, 7 goes into both those. So if I divide by 7 on the top and bottom, I'm going to get 1/3. Okay? So, like I said, just keep reducing until you get down to the simplest form. That's the whole idea. Okay, so now the second objective is to build equivalent fractions. So basically here what we're going to start out with is a fraction and then rewrite it with a new denominator. So the problems are going to look something like this. You'll have 2/3 and it will equal, and they put 6 over here on the side, and you have to fill in what goes in the box on the top, or that blank space. So basically what you're going to do is you're going to divide the denominator. 6 divided by 3 is 2. So that means we had to multiply the bottom by 2 to get to the new denominator. So that means you also have to multiply the top by 2. So 2 times 2 would be 4. And that's your new equivalent fraction, 4/6. Okay, so that's what we're going to do. So to build equivalent fractions, you divide the larger denominator by the smaller denominator, and then multiply the numerator and denominator by that quotient, by what you get when you divide. So let me show you how this works. What you're doing is you're dividing. 8 will go into 64, okay, because it says to write an equivalent fraction with the given denominator. So 8 goes into 64. 64 divided by 8, however you want to think of it, 8 times. Okay, that means I now need to multiply the top by 8. So 7 times 8 is 56. So that's what they're looking there for. Okay, it's 56 over 64. All right. Now, number 2, we have 9/5 equals something over 55. So you divide. 55 divided by 5 is 11. So that's what we're multiplying by. Times 11 on the top and the bottom. So 9 times 11 is 99. And that's the answer there. Okay? On number 3, we have 3/4 equals something over 28. So start by dividing. 28 divided by 4 is 7. So 3 times 7 is going to give you 21. So just make sure whatever you multiply by on the bottom, you multiply the top by the exact same number. All right, here we have 5/6 equals something over 18. Well, 18 divided by 6 is 3. So 5 times 3 gives you 15. So we're going to be using these equivalent fractions in our next section, which works with adding and subtracting. So this is a very important concept. Okay, so here's some for you to try. So pause the video and try these. 5/7 equals something over 35. So 35 divided by 7 is 5, and 5 times 5 is 25. Okay? Number 2, you have 4/9 equals something over 36. So start with division. 36 divided by 9 is 4. So you multiply by 4 on top, and 4 times 4 is 16. Number 3, 3/17 equals something over 34. So start with division. 34 divided by 17 is 2. So multiply the top by 2. 3 times 2 is 6. Okay? Now, number 4 was tricky because you just have the whole number 4 equals something over 3. Well, what you need to do is write a denominator under that 4. 4 can also be written as 4 over 1. Now divide. 3 divided by 1 is 3. So I have to multiply the top and the bottom by 3. So 4 times 3 would be 12. That's the answer we're looking for there. So that one was a little bit tricky. Okay? And that should be it for section 3.5.